to The Long Game, a podcast by Macau Group where we bring you conversations with talented specialists and people who are passionate about what they do in the built environment. My name is Kelvin Moreki and I lead the team here at Macau. If you'd like to learn more, you can check us out at macau.com.au, that's makao.com.au. This is Volume 1 where we focus on energy efficiency in buildings. And today's guest is Clarke from Pro Clima. He'll be sharing his knowledge and expertise on weathertightness, condensation, and other topics. We'll also touch on the impact that a poorly sealed building has on not just liability, but also health, comfort, and energy performance of the building. As always, leave the door to your mind open and enjoy the conversation.
Maybe to begin with, Jesse, it would be best for the listeners to just hear about your professional journey so far. Just your story of how you got to where you are now.
If I go back to what I studied at uni to start with, which was photovoltaics and solar energy, so it was a progressive sort of course to get into because we were the first year of students that went through that and got that actual degree in photovoltaics and solar energy. And from then I went off and started with just a small company doing installation and PV system design for integrated photovoltaic systems, where the PV panels are actually integrated into the roof cladding itself. And
what year is this?
Did that. That's early 2000s.
Okay.
Started off there, yeah.
The pioneers.
Yeah, kind of. It's changed since then. So that all happened at University of New South Wales. They do more generic renewable energy engineering courses now, not so specific on photovoltaics. Yeah, so that was a good grounding. I mean, it was that progressive thinking, and if I had have stuck with it, you would have found that the solar industry is booming now. Yeah. So that's I guess where I like to be in the early days of adoption rather than in the late phases of adoption. But from that small firm I worked with doing the PV installations, I jumped across to engineering consultancy in ESD, essentially, in the early days when the building energy efficiency regulations first came in to the building code. So we're talking around 2005 and doing Section J compliance. I remember when I first started doing that, it didn't exist in the building code. So it was more inventive and creative in that the ESD solutions you put forward, there were no requirements. So it was more just about what should I do to make it more green, if you like. Yeah. And then the building code came in that sort of made it not so fun. Ticking boxes for compliance is not the most fun thing to do. It's always more interesting to try and push the boundaries of things. But I did that for about 5 or 6 years and worked for a year in London doing the same thing, but in the context of the UK. I came back to Australia, and then it wasn't too long after that I jumped across into building products, but more in the resi sector, because the building products company that I went across to was focused more on the resi sector, very large building products company in Australia. Yeah, supplying insulation products and, whole portfolio of products, insulation and cladding materials, bricks and roofing and roof tiles, glazing, glass, so all that stuff. But my main role there was around the energy efficiency side. But started off in the insulation group, learnt all about how the codes and standards work. Also just the sheer amount of detail that goes into insulation and insulation design, but also that all insulation isn't created equal and all insulation doesn't operate the same. And that comes back to basically how it works. Obviously, the R value is important. We all know the R values of insulation, but then the effects of that and how one selection of material has a different outcome, or when you start to introduce the moisture side of things and you start to get into building fabric design. And that's where I started going down this route of, how do we make our buildings perform better, not just from plonking insulation in it, but then how do we add in all the other control layers required to make that insulation work really well. So then we start talking about moisture management and air tightness and all these things that also need to be considered to get really good performing buildings or good performing building envelopes. And that sent me down the building science track, and I went down this rabbit hole and never came out. And
still in it.
Yeah, still in it essentially. So it was about that was up until about 3 years ago, and then I moved across to ProClima and started really, I guess, working in the high end, high performance end of the market, which is trying to push the boundaries and lead the way, I guess, rather than trying to push the way. So it's more of the carrot than the stick, or a little bit of both. So yeah, showing people what can be as to what is standard, which is building code compliance.
ProClima. So now that's where you are with ProClima.
Yeah.
There's a lot you've mentioned that I'd like to unpack, but maybe just to begin with, for someone who doesn't know about ProClima or your company, could you just shed some light about what the company does and the markets it's in?
Yeah, so I would say ProClima is one of the most progressive, if not the most progressive, building products company in Australia to date, because we push the boundaries of what the future will entail. And ProClima is a German-based company, so obviously a lot of that knowledge that was talked about and all that knowledge that was developed probably starting 30 or 40 years ago in Germany, is then being, I guess, pushed across the oceans and towards Australia, which is, these sort of things that we already worked out in other parts of the world come across to Australia. But ProClima started off as in the ecological building movement in Germany. And that was in the 1980s when they started to make more airtight buildings. And the ecological building movement was using natural materials. So we're talking about timber-based materials, we're talking about wood fiber insulation, we're talking about making buildings out of all sorts of materials that have low embodied energy, but also are made from natural fibers. So also things like cellulose insulation. If natural fibers start to get wet or damp, then over time they start to obviously grow mold and then start to decay, and then you end up trading off energy efficiency for severe lack of durability, and the building starts to fall apart earlier than it should. So then the questions came around, how do we manage that moisture, whether that be rain ingress or whether it be humidity in the structure, from entrapment within that building envelope so that building will last for as long as possible. And that's where the durability discussion comes in. And that's then all those theories and that science and the learnings from that ecological movement were translated then to mainstream construction. Because if you keep a building dry, it basically lasts a long time.
That would be a big challenge to deal with, especially that durability thing. Because when you're dealing with natural elements, the durability is one of the challenges you have to deal with, because they tend to react in certain ways when they're exposed to the elements. How do you guys go about, I guess, making sure that, or improving or increasing the durability of the materials or the products that you bring to the market?
Yeah, good question. So I haven't really touched on what we actually sell as ProClima. That's where we came from in terms of the managing the durability of the structures. But what we actually sell is systems that primarily membranes, and they're less than 1 millimeter thick of membrane on the outside of the building, one millimeter thick or less than 1 millimeter thick on the inside of the building. But these membranes, and choosing the right membranes and sealing them up from a water ingress perspective, so stopping water getting into the building, but then for also vapor management to stop water vapor ingress into the construction systems that can then entrap itself behind other materials or within materials. When you get elevated poor moisture content in natural fibers, then they get to a point where they might start to degrade. But the thing that I guess is more complex about it is, well, where is that water vapor coming from, and how do we stop, where's the moisture coming from, which can be outside the building as rain, or it can be inside the building as water vapor, and how do we choose those layers and select the right material properties so that we don't entrap any moisture.
Okay. Nice. Before we dive into the technical aspect, just begin to hear about like the transition from, say, the PV and the engineering space into the building. How was that transition process for you? Was it relatively easy, or what were the challenges? Were there any challenges? But I presume that there are a lot of transferable skills that you came in with.
Yeah. In the early days of my career, because it was consulting, it was a lot of theory-based stuff, calculations according to building code compliance and all that. But before I even got to the point of studying at university, I'd done quite a bit of experience on residential construction sites because my dad was a builder. Mm-hmm. So the transferable skills gone from that, this is how the calculations and the engineering side of things work, but then gone back a few steps and going, well, what did I learn when I was a teenager in the school holidays working on building sites? That was more about how things actually go together. Let's say the reality of building, which is you still have to put stuff together. And that's where the transferable skills came, moving out of that ESD consulting into the building products game, because if you're selling building products, ultimately someone has to put these things together. Yeah. And the more information you can give and the better knowledge and the better understanding of how the products and systems are actually assembled, then that's where you get the good outcomes, because if you can assemble them well, if you've got high quality products with quality workmanship, you get a quality outcome. That's what we're after at the end of the day. And a lot of it is in the hands of the builders and their trades on site.
And in terms of because you were there, I guess, pre-code, pre-Section J and all that stuff. How's the industry changed over the years? Like, from your observation?
I guess it's progressed quite a bit. I mean, there's levers that have been pulled at the regulatory level, energy performance. Mm-hmm. But the energy performance is largely, from where I see it, what I see is it's largely being pushed on paper, not necessarily pushed in reality. And this is the thing that always didn't sit well with me, which was I knew that things were being specified, things were being put in buildings, but they weren't necessarily operating the way they should. Mm. And then you go, well, why doesn't our building deliver that outcome? And it's because, well, you know what really makes it work is that quality workmanship and the way the products are all assembled together. So just having something flapping around in your wall and expecting it to produce some thermal resistance may or may not be true. Depending on the quality of the install. So that's where, I've always went for, I always prided myself on doing things properly. And now I'm just trying to help the whole industry do things properly, essentially, which is get that actual performance by building buildings and making buildings, not just on paper, but in reality. And so they work and deliver the outcomes we want them to deliver.
And would you say the rate of change has been rapid, slow, or just right?
I think for me, it's slow. Mm-hmm. The construction industry is slow. It's where do you want to operate within that construction? Where do you want to operate within the construction industry? Because there's all different sections of the construction industry. So you obviously, like any, I guess, process of innovation, there's the early adopters, the late adopters, and then right at the back you got the laggards. So who do you want to work with? Do you want to work with the laggards and drag them kicking and screaming? Or do you want to work with the early adopters and the mid to late adopters or whatever? But push that high end, who are a lot faster and moving a lot faster. But to some extent, I feel that there's often even that group gets held back by the mainstream and by the building code, because the building code doesn't necessarily allow easily a super high performance international best practice building to be built, because then you run into the certifiers and saying that's not compliant. Mm. And then you've got to justify that it's actually better than compliance. But how do they know? And to be fair to them, how do they know? And
how do they know?
It's like you're building this thing, but that doesn't meet the standards. It doesn't meet the code. Well, it's not built to the code, and then you've got to try and explain why it's better. So to answer your question, is it fast? Depending where you're operating. I think there was, from when I did the change from mainstream building products to high performance building products, that was a big transition and super fast for me. But in terms of in context of the whole industry, no, because not everyone's doing it. And there's a small amount of people that are doing this high performance stuff.
Do you see a commonality in terms of the people or the groups or entities that are working in that high performance space, that high end of leading the way rather than just the tick box kind of stuff?
Yeah, well, I think it probably all comes back to the business model, what you're using to essentially make money. And I think there's a lot of people at the high end that say, look, we pride ourselves on delivering the high performance, and our business model is to give you the super high quality, and you get to pick up those customers and those clients that want that super high quality. But I think most of the construction industry is geared towards building the cheapest possible building you can possibly build and selling it for the largest possible sum of money you can possibly get for it. There's way too many people with that business model, and not enough with the business model of I'm going to show you or deliver you the best building you can possibly have. But you're going to have the money to pay for that as well, obviously, because it's not going to be as cheap as the cheapest possible building to build.
So there's always a trade-off.
Yeah.
I think we'll probably start to get into slightly more technical domain, which is where Roberto probably know he has a few questions in that space. I know you've ProClima has recently released the Blue Book. Been skimming through it. Could you just tell us a little bit more about what it is and maybe the goals and just tell us more about the Blue Book.
Yeah, okay. So this, I guess, off the years of learning that I've had probably over the last, let's say, 10 years and progressing through this building science learnings and the story around building science, what building science allows you to do is innovate. So it allows you to move outside the world of brick veneer or lightweight drain and ventilated cavities on the outside of residential buildings, or traditional precast concrete with interior insulation, and that's the way we've always done it, therefore it must be right. So the innovation process and understanding the building science and how to layer these systems to stop water coming into the system and prevent entrapment of water vapor is really important, because what has happened in other parts of the world, people innovating and not understanding this whole moisture management process, is that you run into this really poor moisture balance within the structure, and your building end up having bad outcomes for health or durability. So the Blue Book was then outlining, hey, here's some ideas around how you could develop new construction systems or better construction systems, taking you from standard practice, which there are a lot in that book, to things that are what's considered, only the Europeans would build that sort of style construction systems. But there is a fundamental reasons why the Europeans build it that way. It's not just because they like to spend a lot of money and have too much money to spend, and therefore want to flush it down the toilet on really expensive ways to build. And it comes back to those discussions or those arguments around health and durability, which, by the way, will probably deliver you a more energy efficient building, because it will have less thermal bridging and all sorts of other value propositions to go with it. So anyway, the Blue Book is outlining those systems as a first port of call to say, hey, why don't you consider any of these systems? And you can calculate it. And it was also laying down a methodology and a thinking process to enable us as a country to go, okay, now let's do 400,000 calculations and work out exactly where all these construction systems work and where they don't work. I just don't have capacity myself to do 400,000 calculations. So I need every engineer in the country to help me.
Distributed approach.
Yeah.
Or more, decentralized approach.
Yeah, collaborative.
Collaborative. Yeah. Oh, nice.
We'll have to create some wiki or something where someone can just post all their answers and their calculations. That would be awesome. Yeah, share it all and just trade solutions.
Yeah, that would be. I'd be keen to see if that would actually work. Roberto, feel free to jump in with any questions.
I was going to say it's important to mention. I'm pretty sure Jesse offers training courses on WUFI modeling.
Yeah, WUFI.
That's one of the key tools to perform all the calculations.
Yeah, correct. So WUFI is not the only tool out there, but it is the one that ProClima is promoting, and we work with the Fraunhofer Institute quite closely, who developed that software, and that's been in development for over 30 years, let's say 40 years. So this discussion, like I said, in the 1980s back in Germany, they were having this discussion around moisture and started the research. So what I would like to do and what I'd like to see is piggyback off what has already been done and experienced internationally, rather than try and reinvent the wheel. And I think there's just too much of that let's reinvent the wheel happening in Australia. And because we've only got 25 million people, as opposed to 300 million in Europe and another 300 million in the US, who has more people that are looking at these problems, brain capacity looking at these problems to help solve the problems? Well, it's internationally, there's a lot more people that are thinking about this than in Australia. So anyway, on WUFI, yeah, we do train on WUFI. It's a hydrothermal analysis software, looks at the heat and moisture flows within building envelope, how you layer those material layers so that you don't accidentally put the wrong material in the wrong location, in the wrong climate, in the wrong building type, and create a massive problem, liability for yourself. And then the lawyers have to get involved. So if we can keep the lawyers out of it, then we're doing well.
Liability is always a big thing.
Yeah, and this is is actually a big driver of a lot of this moisture stuff, as opposed to energy efficiency. Because energy efficiency, it's like, well, tell me one person that's been sued for not meeting or accidentally having a thermal bridge that shouldn't be there, or a missing piece of insulation. Are there any cases out there?
Not off the top of my head, yeah.
Yeah. But when you start to get moisture problems, particularly water leaks, then you start looking at, hey, shout across the ditch to New Zealand and say, what are you guys doing? And they'll tell you that they've got $47 billion worth of damage from a leaky building crisis because they tried to innovate and didn't quite get it right.
Wow.
So
$47 billion.
Well, that's from Peter Dyer's book. That's what he quoted, an extrapolation. But yes, something like that. But the exact number is not really known, but that's the estimate.
Is that from just internal or just external moisture?
This is combination. This is the $47 billion question. So up until now, Brands has been focusing largely on the water ingress, because obviously you get a water leak that can deposit a lot more moisture into your construction system a lot more quickly than vapor diffusion. So Brands, if you don't know, they're the Building Research Association of New Zealand, and they were set up a few decades ago to try and solve this problem. And a lot of the building codes in New Zealand have been progressively updated to help solve that water ingress problem. And now the conversation's slowly moving towards, okay, we've got more weather-tight buildings, but what about this secondary moisture source, which is the humidity inside the building that can then entrap itself in the wall and roof systems and cause condensation, high humidity in the material layers, particularly on the outside of the structure that gets quite cold. So those weather-tight layers on the outside of the structure that they've been progressively pushing for the last 2 or 3 decades, then once they're properly weather-tight, they're airtight, and they can potentially be barriers for condensation. So then all of a sudden you go, okay, we've got more watertight buildings, but we've got buildings that are now trapping water vapor in places we don't want them to trap. We don't want it to be trapped. So that's where all the building science starts coming in. How do we balance this relationship between the waterproofing, the energy efficiency, and the water vapor management, so as to not create high humidity and mold or corrosion or timber rot or anything else that might happen?
And how do you navigate that trilemma?
You start with weatherproofing, number one. Weatherproofing is the most important. That's why we have building structures, to stop water getting in. And if I sit here and say that no buildings in Australia are waterproof, is anyone going to tell me I'm wrong? I would say just about every building in Australia would leak water to some extent.
To some extent.
Yeah. And the question then is, okay, if it does leak, or sorry, not if it does, when it leaks, how does that water dry out? So you're building in a resilience or a drying potential, capacity to dry out. That's what you want in your building envelope. That's what you want in your structures. So it's the what if my building fails scenario, or not what if, or when it fails, then how's it dry out? So you have capacity to dry out water leaks, but you also have capacity to dry out what if no one opens my windows in my house, or no one opens the windows in my apartment? Can it still permeate through the building envelope to an extent not to create big problems for myself? I was going to say weather tightness is an interesting one, because I keep raising this in energy efficiency discussions, and some people will look at me going, what are you talking about? This is not anything to do with weather tightness. But a more weather-tight building, or a truly weather-tight building, will actually deliver a level of air tightness whether you like it or not. Because to make it weather-tight, you've sealed everything up. You've sealed everything up to stop the water coming in. Now you've created a more weather-tight building, more airtight building. And one of the big examples of this is multi-residential buildings and precast concrete. So to get a precast concrete system weather-tight, you have sealed joints between all the panels, normally two a pressure equalized joint. So you've got two seals there, and therefore it's becoming airtight. And you've got this around all your apartments, and the only way that air can leak into that apartment is through the window suite, mainly. So you end up having these sealed boxes, and this indoor humidity goes up and up because we've got no humidity management. And then over the years, you progressively just push more and more water vapor into the precast, into this, which is on the cold side of the building envelope, which then elevates moisture content year on year on year on year. So then 5, 6, 7, 8 years down the track, you've got this soggy precast around your whole building. And then what happens to all that water? And this is, it's just a complete lack of thinking about durability and long-term performance, which is not regulated yet.
Which is where now the liability and all that stuff comes in.
Except that you only have builder's warranty, which isn't normally longer than 5 to 7 years.
7 years.
Which, in my opinion, a building should last a lot longer than 7 years.
Than 7 years, for sure.
We should be talking 10 times that, 70 years, and then we're in the ball game.
That'll be the dream. Once we get to thinking along those timescales. Yeah. So I see where if you focus on the weather tightness bit, by extension, you kind of resolve all the other issues of air tightness and then energy efficiency as well. When you spoke offline, you did mention that how we talk about energy efficiency can shape the end outcomes that we have, and instead we should be, beginning the conversation around whether it's health, comfort, durability, and then from there move on to these other elements. Could you just touch a little bit on that?
So, on how all these things are interrelated: health, comfort, durability.
Yeah, or using that as a core focus, and then that kind of permeates towards the energy performance as well.
Yeah, okay. So energy performance, or making better buildings through driving energy outcomes, in my opinion, is difficult because energy is so cheap. So therefore you do the cost-benefit analysis purely based on energy, purely put in insulation and better glazing, and you go, all costs way too much, and the payback is going to take me, way too long, and therefore it's not viable. If you then come back and say, okay, what about the health discussion and what's the value of health, then all of a sudden you've got to start answering the question, well, what's your health worth? So it depends if you're trying to prove this to the government or prove it to yourself. But most people in Australia would probably say that their health is priceless, and it's of higher value than anything. So you want to be healthy. And I could ask 100% of people, I would say, yes, I want to be healthy. I don't think there's anyone out there that's going to say, no, I don't want to be healthy. So if we have a discussion around healthy buildings and what makes a healthy building, then we can probably drive, or hopefully drive, more value that people will resonate with the people, that will lead to overall better buildings. But when you mentioned comfort, something I always say is, a question for you is comfort a luxury, or is it something that we must have?
Personally, I think it's something that we must have.
Yeah, so comfort to me is just a metric for health. So if you say what's thermal comfort, you're actually saying, well, what's the thermally healthy band that I should be living in permanently? It's not a luxury that can be traded for, say, energy efficiency. So if I say, okay, I can trade, if I could trade my comfort for energy efficiency, I'd just say, well, let's just have a temperature range in my house that goes from 5 degrees Celsius to 45 degrees Celsius. And all of a sudden, well, that's not healthy. No, it's not healthy. So what is healthy? And we've got to have a discussion around what's the healthy comfort band, but also what's the health of the building in terms of other metrics like, mold growth, which we talk a lot about as ProClima because it's related to moisture. And that's the first thing that happens when you get too much moisture. You start to get mold spores. Indoor air quality issues, a lot of, well, if you pile all these in together into the one basket and say, okay, what's the value of having buildings that aren't moldy? They've got really good indoor air quality. They're in a thermally healthy, always in a thermally healthy comfort band. Now, tell me what that's worth, not the dollars of energy that I'm going to save. And if you can move the discussion that way, which is not an easy question to answer, by the way, what's the value or how much health, what's the dollars figure for the health savings? If you can move the discussion that way, then hopefully we can have more, it will stack up better from the cost benefit.
Yeah, it's funny because when I first started this particular series, I called it energy efficiency, so volume 1, energy efficiency in buildings. But interestingly enough, all the guests that have come on board have pushed the conversation towards that of health and comfort rather than energy efficiency. So I'll probably have to change that title towards the end of the series.
How do we make the existing buildings healthy? That's one of the things that I've been questioning myself. I live in a double brick house. I've been talking about moisture ingress, speaking to Kelvin before this recording. Like right next to where my son's sleeping, I have plaster peeling off the wall. So, and that's pretty much like the bulk of the vast majority of the buildings in Melbourne. A brick facade, and we try to talk to a developer or someone's renovating. Well, there's an opportunity here if you're extending the house to have a better weather-tight envelope. They don't want to have any loss of floor area. So there's a mix. Some people, they perceive the benefit of a healthy building, but some others, I still believe it's more important to have a large floor area and an expensive kitchen and a proper envelope, proper execution of the installation.
Yeah, so it's the ROI driver, the return on investment. And people are largely looking at all the real estate and all the whole construction industry in that through that lens, which is largely, it creates, the construction industry creates a lot of revenue for everyone from at all levels. Yeah, it ultimately comes down to, does the consumer or the person paying for that building, whether it be residential or commercial, do they value all that extra stuff that you're putting in there that is not just purely bling that people fork out extra money for? So all the stuff that's hidden in the walls and hidden in the roof that is unseen, do they value that? And then do they value the other outcomes of that, health and durability? And it's a hard thing to communicate easily and simply.
I think it's probably an opportunity to expand the requirements of condensation management in the NCC. Some of the clients that comes to me, they just go, we tick the box that they deem to satisfy. Of all those years, I have done one condensation modeling for a client in North Queensland for like a cold room, so nothing related to residential.
Yeah.
So we're going, it's pretty clean, it's deemed to satisfy. We tick the box. As an example.
Yeah, exactly. And that was a cool room, did you say?
Yeah, cool.
Yeah, so it was some sort of commercial client, or like a large client. Yeah. So it's a difficult one, but I think in the residential side of things, you're going to be pushing it to get people to do condensation analysis on residential homes. It's going to be more driven by holistic analysis and people crunching many permutations to work out what works in different climate zones. In the commercial segment, well, as you said, the condensation requirements, they only apply to, in the building code, only apply to class 2 and class 4, which is dwellings, and class 1, freestanding houses.
Yeah.
So it's basically where people live. So where you've got lots of moist people inside the building doing stuff that people do, cooking, bathing, showering, having cups of tea, whatever you do that produces water vapor, and then creating condensation. And basically, this whole discussion needs to be carried across to all building classes, because it needs to be carried to hospitals, schools, aged care, all these places where we've got people that are, that we care about, the elderly and sick people and our children. We should make sure that we're not getting mold growth or perverse outcomes happening within the structures of those buildings as well. But if the building code doesn't suggest it's a problem, or doesn't even tell you to look at it, then, hey, guess what? No one's going to look at it. Doesn't mean it's not a problem, though. So as we talk about future trajectories towards net zero, then we will have more insulated buildings. We will probably have more weather-tight buildings as we get better and better at doing that, which means we probably will have more airtight buildings, whether we decide to regulate air tightness targets or not, or tighten the air tightness targets. So all these overlapping factors mean that we have to worry about water vapor, and we have to worry about moisture in our building envelope. And that goes across all building classes. So it will get more, and there will be more calculations being carried out in the future. It's just a matter of when.
Maybe just taking one step back for the people if a listener doesn't have an idea or is unfamiliar with the concept of building science, how would you, just from a systems thinking perspective or a framework perspective, how would you describe it, and why does it matter?
So I guess those that have looked abroad, and a lot of people have in Australia, they've worked abroad, a lot of engineers, they've often grew up in other countries, and they're the people that really see it when they come here, which is how different construction practices are in Australia to other, I guess, more progressive countries. But what's happened in other parts of the world, there's been this relationship between energy efficiency and health. So this kind of, we increase the energy efficiency regulations and we create unhealthy buildings. And a lot of that gets pinned on, the buildings are too airtight, but that's not true. I can explain that more. But basically, you need to start to look at how pulling this giant lever that says you must jam more insulation in your buildings and you must retain more energy in your buildings means that there's a flip side to that coin. And that is that you're going to create an equal and opposite reaction. And if you don't look at what that is or don't pay any attention to it, it's essentially moisture. So the moisture then starts to accumulate in places you don't want it, and you start to get mold growth and unhealthy buildings, mold spores and all sorts of poor indoor air quality problems. So building science is about developing construction systems, or let's say building envelope science is about developing construction systems that manage energy efficiency or thermally effective in what they do, but also will remain dry and healthy.
Nice and succinct.
So,
that's the best definition I can come up with around what I do every day.
Technically speaking, so I have a question. We talked about energy efficiency. We measuring kilowatts hour per year. Condensation risk, it's the mold growth index. Can you explain a little bit what's the benchmark in the BCA, or how your Blue Book refer to the area, the A07?
Yeah, okay. So there are new benchmarks. Well, actually, in the 2019 code, there's nothing. It's quite vague. You can carry out a calculation according to a certain set of criteria, and it's left up to the engineer. Or you just do the DTS, which is you've got to have certain amounts of vapor permeability on sucking type materials in climate zone 6, 7, and 8. In the 2022 code, which you may have read through the draft, which has come out and public comments just closed, but they're talking about increasing the climate zones that need to have vapor permeability, so moving that up to climate zone 4 and 5 as well, which means that Sydney, inner city Sydney, Adelaide and Perth are all included in that as well. Then inland New South Wales and South Australia and WA in the climate zone 4. But essentially, that's a prescriptive method, just having this vapor permeable membranes on the outside of your building. If you then go down to the verification method, it's talking about calling up ERA DA07, which is the hydrothermal design criteria for buildings or building envelopes. And that is essentially the rule book on how to do a hydrothermal simulation using a software such as WUFI. So there's a lot of assumptions, and you guys have done calculations on the energy efficiency side using these rating tools. And when you get into some of those rating tools, there's probably, it could be 1,000 different parameters you can change to get a different answer. So it starts to lock down some of those parameters and create consistency in the assumptions. And by doing that, we can then use it as a compliance method because everyone's calculated under the same conditions, basically. So anyway, so that rule book sets things like how you calculate the indoor temperature and humidity, how you calculate the indoor temperature and humidity, what happens when you overlay ventilation into your building, like continuous mechanical ventilation systems, and you start to lower the indoor humidity in the building. And then you can calculate with using the material properties in terms of the moisture storage of those materials and the vapor permeability of those materials, whether you're likely to entrap moisture, depending if you're building that building in, say, Darwin or in Hobart. And obviously in Darwin, you're cooling the building 95% of the year, and in Hobart you're probably heating for 95% of the year. So two completely fundamentally different outcomes you could get for the same construction system in those climates. And that's what the ERA DA07 allows you to do. Yeah, it's setting, I guess, what I would say the pathway for innovation on construction systems to net zero without creating perverse health outcomes in your buildings, which is what we need. And one last thing, it was adopted essentially from the ASHRAE 160. So a lot of that intel, a lot of the IP, or all of the IP, I should say, is a collaborative effort, international effort between a lot of the smartest people in the country from the US, Lawrence Berkeley National Laboratories, Oak Ridge National Laboratories, Fraunhofer Institute for Building Physics, all collaborating to come up with those those algorithms and the inputs required in those calculations.
Just circling back to the topic around better buildings or better quality buildings, I know you've worked with a range of clients from builders, developers, and individual homeowners as well. Just based on what you're seeing, where would you say we collectively are roughly now, and where should we be, or at least where should we aim to be in the near future? The trajectory towards
where are we? Is there an end to it? Is the question.
Is there an end to it?
Is there an end to better buildings, or we just it's like anything, you can't say there's an end date and that's where we need to get to. Although in term, what the important thing is to understand, well, what are we actually aiming for?
What's the goal?
Or we just increasing the code for the sake of increasing the code, but we don't know what actually we're increasing to try to achieve.
Mm-hmm.
So what does that end thing look like that we're aiming for? And the best thing I can point to at this point is Passive House and say, look, yes, it costs more to build at this point in time, but it's there and it ticks basically all the boxes from all sorts of perspectives, because they have been through this process in other parts of the world and they've screwed it up in terms of this balance between energy efficiency and health. Passive House went through it in the early days and went, oh, we're creating problems here. And then that's when all this stuff around moisture started coming to discussion, and vapor control layers and weather resistive barriers on the outside of the systems, thermal control layers that are properly implemented, selecting the right insulation type, not just an R value. All this comes into the equation. And Passive House is, well, if we look at that and say, well, we should be aiming for something that looks like that, then we're on the first step, because we're just talking about having continuous mechanical ventilation in the 2022 code for buildings that are under 5 air changes at 50 pascals. And we're talking about having air tightness targets which were set in 2019 at 10 air, or air permeability of 10. But that's nowhere near where we should be, which is air tightness down at 2, 3 maybe, and then we talk about a good code level. So how many iterations of building code to get there? We're talking another 3, 10 years. That would be nice.
10 years.
10 years would be nice if it is seriously updated every revision, every 3 years. There's an actual update, and it doesn't wait 10 years like the residential side. It was over 10 years before, when it went to 6 and just moving up to 7-star equivalent in 2022. So if it takes 10 years to shift the residential code, and that's how long between revisions, it's going to take us another half a century.
Yeah. So hopefully we can fast track it at some point.
Yeah.
Just had a question around because you did mention that regulations and policy do tend to impact what the industry ends up adopting in the short term and also in the long run. I'm just curious to hear what your take is on the new code, whether it's the 2019, and you've touched on a little bit in your previous comments, but just keen to hear what you think about what's been proposed so far.
I'll answer that in the context of residential, because that's where the majority of the changes are happening from that 6-star NatHERS to 7-star NatHERS equivalent.
Yeah.
But ultimately, the way I see it is the elemental provisions, the lookup tables in the building code, they should be really basic. They should be set at insulation levels which are relatively high. And if you want to value engineer a project, then you should have to calculate it. And that means if you want to use light or dark coloured claddings on whatever climate zone you're in to get a zero cost or zero reduction in the energy efficiency, zero cost reduction in the energy efficiency, then you should have to contract someone to calculate that out for you. But if you just keep it simple, I think that's one of the keys to the elemental provisions, and not have this super complex tabular lookup tables. But the other thing with the building code is that, yes, it's minimum compliance, but what it shouldn't do is hinder the market leaders from building best practice. So those people that want to do best practice often get pulled back by the certifiers because they say that's not building code compliant. And then you've got to justify why it's better than building code. So if they have those mechanisms and understand what best practice is to allow that to happen rather than hinder it, I think that's a win in itself, because then the market leaders, and we can get more people out there showing how it's done.
I'm just curious how the conversation goes with the certifiers whenever you present something that's obviously much better than the code, but because it's maybe outside the realm of what they handle or deal with on a day-to-day basis, push back on it a little bit. How does that conversation typically go?
Well, mainly it comes through the grapevine. So there's someone that's out there trying to sell a product or a system, for example, one of our distributors, and they come back and say the certifier is not accepting this for X, Y, Z reason. And then I say, okay, well, there's a couple of ways we can, try and convince them, have a conversation with them and educate that certifier. But what the certifier is trying to do is cover their ass from a liability perspective. If there is no clause that says it's all right, or no standard that says it's all right to build that, I can see why they're reluctant to certify it if they don't understand what it is. So often it could just be a conversation saying, look, this is the way it works and this is what we're doing. Here's some content and some literature around how it is and what it is and how it works. Other times it can be a lot harder and they won't move anything unless you've got a full code mark certificate. With the code mark certificates, then it's like, well, what are you code marking against? Because does that meet code, or is it better than code? Or anyway, so it's a difficult, sometimes it can be difficult, but ultimately it's an engineered solution at the last resort, which means that an engineer has to sign a bit of paper, and anything goes wrong, then they're the ones that have to sit in court and explain themselves. But if you know what you're building works, then you shouldn't have a problem signing that document.
As we start to wind down, what's next for ProClima? What does the near future look like? Are there things that you're working on, products you're bringing to market? spaces you're getting into?
I mean, we'll keep innovating and keep progressively bringing more products to market. I can't specifically say what, announce to everyone what we're doing.
Yeah.
But put it this way, internationally, we sell a lot more products and a lot more systems than's available in Australia. And that's not because we're holding Australia back. It's just because we need people to understand the systems that we do sell before you start introducing new ones. Because obviously anything new takes time to learn how to apply and install. So yes, we'll be bringing new stuff, and as airtightness gets tighter and tighter through the building code or otherwise through market leadership, then there'll be room for new systems and new innovations in the airtightness space and the weatherproofing space. I mean, we've got a lot of catching up to do with the rest of the world, making properly weathertight buildings that don't leak water, and I think there's a lot of potential in that market for doing things a lot better than what we're doing now.
Early on, you mentioned about the quality of the installation or the install during the build stage impacts the end performance of the building. Is that a challenge that you see in some of your products, and how are you kind of shaping the improvement in terms of that particular stage of the build?
Yeah, so that's primarily where quality construction will come from, which is the application side. But we have in-house application expert. So Daniel Jacobs, you should have a chat to him too at some point. Yeah. But he's got decades of experience from Germany as well. And like I said, being 30 to 40 years ahead of us, it's a lot of the problems have been seen and been solved. And a lot of the time it's like, we used to do that back in the 80s and 90s, but we sort of got rid of that construction practice. It's difficult sometimes if you're too far ahead of the game, but it's the only way you can sell new products and new systems and better products and better systems is to upskill and educate. Otherwise, you just end up competing with every other company out there selling, the cheapest method of doing the same thing.
And which two professions do you think should talk more to each other so that we can get better quality buildings? Or it could be more.
Are you you want me to say the architects should be speaking to the builders more? Or?
No, I'm just because it's something that came up with the last podcast we had, where during the design stage, just having a conversation with the builder does help, because there are things that are very hard to either change or amend or fix once the construction phase has begun. But then there could be other professionals that can influence or impact or add value to the project as well, that might not be might not be involved in the conversation. So I'm just curious to hear that is from your vantage point.
I mean, that's absolutely right, because in the architectural field, I guess it would be nice if things were detailed to a higher level of detail, so that the builders didn't have to make up details on site. So it depends what sort of building you're dealing with and what scale of building. But ultimately, the more details drawn and developed that are actually buildable details, then the better things work. The more you leave up to the builders on site, the cleverer they have to be, essentially. But it costs money to detail stuff to a high level, to 1:2 scale, to draw a full scale drawing of something to get a minute detail right is expensive. But these will evolve over time, and details are an important part of this. But this is where something like Passive House has got it absolutely right, because it's not just a certification system, it's a quality control system, in that they actually look at every detail and every junction and say, okay, what are you using? How does that work? And have you done the thermal bridging calcs on it? So once we get to that level of detailing and they become normal details in the context of Australia, because you don't need as much insulation, to be honest, as you do in Scandinavia. So you can build a passive house, for example, with a lot less insulation than you need in northern Germany or something like that. We need to have those standard details, and they need to be freely available, and they will be, and they'll start to evolve, and more will come. But also on the weatherproofing side, and details that actually work, not details that are just dreamt up. and all the weatherproofing and facade testing that's going on off the back of building code changes that happened back in, I think 2015 it was, in terms of full-scale weather testing. So that's we're talking about 5-6 years down the track, and there's all this knowledge that has started to build up around how to properly detail drainage systems and flash-ins and how to connect things into windows, how to connect the membranes into windows, make sure they don't leak. It's all important details. And this is all part of the future of buildings, which are not directly related to energy efficiency as such in terms of energy savings, but they're directly related to the ability of the building to remain dry, which is also related to how you insulate the building. So you have to think about all these design problems, and fire overlaid on the top of that, because obviously insulating with the wrong material in a high-rise building isn't a good outcome either. All these things overlapping, and then you get into what's known as building enclosure design, which is a whole discipline that's missing in Australia. So you go to Canada, for example, and a building enclosure consultant will be the consultant that pulls all these things together, talks about all the things I just mentioned, and draws it in details and detailed junctions so that they will actually work.
It's similar in Brazil. I've been doing a lot of lead projects for some of my counterparts in São Paulo, and they have a specialized discipline. It would be building ceiling or like a permeability group. So there'll be someone specialized to do the detail on the section, or the tapes and air tightness membrane. In Australia, no one knows. I'll be in contact with an architect, who does that.
Yeah.
We're not responsible for it. It's the facade engineer. The facade engineer, it's not us. So we can look at the air infiltration of the facade system, but we don't look at integration to the envelope.
Yeah. So it's a whole discipline that overlaps with facade engineering, with ESD, and with mechanical engineering, because they're the guys that are responsible for temperature and humidity inside the building. And then actually understanding on a really intricate level of detail how buildings go together. There's a big hole in the market, so if you want to fill it, go for it. Market opportunity. New consulting firm. Building enclosure design, that's where it's at.
The future. And as a last question, are there any people in the industry that you follow, pay attention to in terms of content-wise, or just their work from a professional vantage point again?
I mean, there's a lot of, I can't call out any specific, there's a lot of really good designers, architects, engineers in all the space, everyone that ProClima works with, but also the builders. I was recently on Instagram stalking people that were using our products on Instagram, and I was super impressed with some of the details and the innovative solutions they're coming up with, because as I said, it's not off-the-shelf solutions that we as ProClima sell, and there are hurdles that you have to overcome. And some of the stuff going on is fantastic in terms of the quality and what people are delivering. So no, I'm not going to call out anyone specifically and say but there's a lot of good stuff happening, and I can give you specifics after the podcast if you want.
Yeah, sure. I totally understand. But thanks for making time today. It's really intriguing to hear more about what you're doing, what ProClima is doing as well. I feel like there's a lot more we need to probably unpack, but we'll save that for a second conversation. Funny enough, I was thinking about health and comfort as the next series, which seems to be should have been this particular series, because it can't really separate health and comfort and then energy efficiency.
No. It's a building as a system. That's what it's about. They're all interlinked.
They're all interlinked, yeah. But yeah, thanks again, and I'm pretty sure we'll be meeting up most likely in the new year.
Yeah, excellent. Yeah. Thank you very much. Thanks Kelvin. Thanks, Roberta.
Cheers.